So we're back again, and the normal reminder, if you go look at the bottom of the video on YouTube, if you open up the description, we got links to lots of things or several things down there. We got the link to the index, so it'll have the index for uh, actually the index is built right there. So it'll have the index for this meeting, and then it'll have a link to a composite index that's got several years worth of videos that we've done, and it's got a link out to the YouTube channel where it shows the all the videos are stored. So you just go select the one you want, and then I've got an index to the old original ROS agriculture index that I started one time, and I think there's a link to the Slack channel. And again, I don't have it in front of me. I need to write. I should write a piece of paper that says, "Here's the things we have," and then better, I should just have a video that says, "Here, go watch this video and explains all this." But we don't have that, and I'm that at the moment that's not my top priority. So what I have done or not done, I continued on with my data logging and I was looking at the heating system of my house, and it kept getting cold. It'd get cold outside, it'd get cold in the house, and finally they sent out a letter saying, "Oh well, yeah, your house is cold, and basically we don't care." Paraphrasing that's paraphrasing the whole thing. It says people were complaining, so we're putting out this letter saying we don't care, but we'll continue to monitor it. So they basically said they don't care and they have no idea what they're doing. And then a few days later, I noticed on my data logs that all of a sudden I could see at 12:37 p.m. they had turned the knob on the boiler and cranked up the temperature a few degrees on that, and that seemed to solve most of the problems. And then over like a week or two, I think they maybe a couple of times tweaked it up a little more, and it seems to be acting the way it should now. So that other than that, I'm just going to ignore it. I've got the thing; it just constantly runs. So once a day, I get a 24-hour log file of what has happened over the last day, and then it just automatically starts a new one at midnight. So that just is going to be now self-running, and I'll just look at it occasionally, see what's going on. But I will say, yeah, I learned a lot about data logging and what to look for, and then I learned a lot about trying to analyze the heating system and figure out why it's doing what it's supposed to, and try to figure out what it should be doing. So that has proven to be fairly useful. And I think I said one time that I wanted to get the temperature on the other side of the room. So I put a Dallas one wire temperature sensor. I wired it next to the thermostat, and I've got about a 20 to 25-foot piece of Ethernet cable connecting that running across the room. And that does indeed work. So if you want to put one of those sensors on a long cable, I saw one guy made the comment. He says, "Oh, I put one on like a 100-foot length of Ethernet cable one time, and it worked for him." So I was worried that he can't get more than 3 feet or something, but for some reason it works, and I don't know why. So let's see, that takes care of that. The other thing I was noticing when I was going through, but I'd started my small robot one time, and can I conveniently pick this up? What's this do? So this is the small robot that I started one time, and there's various entries into this on the. If you go look at the index, and this is the thing's got the giant RC servo to run the steering. The steering linkage looks like that, and then in the back, I added on two drive motors, so each motor drives one side, and one of the reasons for doing this, I want to see, can I run those two motors off a single channel and get it to work like a mechanical differential? And I think of a wireman series, I can make it work. And then I want to check to see can I wire it parallel and make it work. And the reason I'll know it's working because each motor has a quadrature encoder on the back of it, so I can put it on the ground and say drive in a circle, and then go look to see if everything's coming out the way it's supposed to. But anyway, I got at the point to this point, and I just have to put some electronics on it and then write some software to control the low level stuff. So I got to that point, and then it sat around for about a year or so. And then when I was going through cleaning out boxes, trying to find out what I have and how to organize it, I found a lot of parts that I realized later that I guess I was much further than I thought, because I had one of the this is one of those. ST Micro. It might be one of the versions of what they call a black pill, but it's got the F401 processor on it. And I thought, well, if I just put one of those on and put some code in it. Well, when I was doing that thing with the those encoder wheels for my bigger robot, where it just, you bolt it on and it just rides on the top of the tire, I needed some way to read those. And I took one of these boards like this. I thought, well, I just need some code. So I went and looked. Oh, there's a project that already had stuff that would read quadrature encoders. And I think it's the code I started to run this robot. So it's really down to the point where I just need to take all these parts that are laying around and wire them onto this thing somehow and hook it on with duct tape or whatever I want to do. And then load the code in that I've already got, because I might even have the odometry code in that thing. So it's just a matter of I just need to sit down and do it. And one of my dilemmas was, if I've got this board like this, so here's the board I was just showing you. So I can either plug it into a proto board, and they just have, say, put a perf board next to it with a connector to hook up to all my stuff to run wires back and forth. And the advantage of that is being a proto board, you can pull the wires out, move them, just pull it out one hole and put another hole without having to take the whole thing off and get out your soldering iron and move wires around. Or, just start off with a perf board, like that, and just have it so it, put socket strips so it just goes right on the board here. And then next to it, I can put up my header pins to make my connectors and put it all on just a nice clean little board like that. But then, as I say, if you want to make any changes, you have to take the whole thing apart and get your soldering iron out and move the wires around. So that's one thing. It just keeps, I just keep going back and forth. Oh, do I do this, do it this way or do this way? It turns out either way is really fairly minimal to put it together. And I can just at any point throw the whole thing out and just do it the other way without any real dilemma. So I should quit worrying about that and just go ahead and hook the thing up and do it. So I was looking at that the last couple of days, and I've got enough parts laying here. I basically have all the parts I think I need to make it work. And the other thing was I'm just basically trying to duplicate what's on the Sammy, the bigger robot. And this from to do my remote control system. Here's that board from Adafruit. It's got a SAM 21 ARM processor, and then it's got a LoRa module on there. And this is what I used. I started off, this is what I was going to have on the Sammy robot. But then since I had my extra requirement, I wanted to try to duplicate the industrial remote control system we had on our big tractor at Danfoss. And in the process, that would connect with a CAN bus. So I had to have a processor that would talk to a CAN bus and send my messages that way. And it turned out this board does not have the built-in CAN peripheral in this particular processor chip. So I went back and I found out I can take a Teensy 3.2. It's got the peripheral that I need. And then I bought all these things from Adafruit where you can buy an adapter that'll adapt the Teensy 3.2 to what they call their feather standard. So it's just a board that your processor plugs into and then gives you pins. So you can plug a feather module on top of that. So I went and bought one of their radio boards that's basically just it's the feather configuration, and then it's got one of these modules on that I've just shown you. And so you stack all these things up, and then I ended up with just the only real difference between the whole thing is the fact that one will do CAN and one will not. So on that one I ended up throwing out. This is the board that was going to go in there, and I apparently didn't put it in because there's no pins soldered on it. But then I realized, well, it won't do CAN, and I modified that one. So it's got one of these boards just like this inside of the remote control module. And it turns out the Adafruit thought it'd be real cute to put a battery on the thing. So here's, I guess if I look at the right side of it. So down here, there's a connector. You can plug in a lithium battery into that. That's got the charging circuit and everything built into here. So whenever you got the USB plugged in, it's trying to charge your lithium battery. And then when you unplug it, this thing just runs off that battery. And it would have been handy if you put a switch in between, but they didn't. And it turns out that in the remote control module, this worked out great, except I ran out of IO pins because since they put the stuff on it that uses up some of the some of your IO pins. You're missing like 4 or 5 IO pins, and just basically I was just taking the pins from here and hooking up to switches and LEDs and whatever on my remote control thing. So I was thinking about taking that board out and replacing. I've got a Teensy 3.5, and that's got like it's like a 40 pin device. So it's got tons of IO on it. And then you can buy just the little radio module on a separate little board. So if I wire those together, that would take care of that. So I'd replace the radio in the radio and the controller inside of the remote control module with the one simply has a way more IO on it. And then on on Sammy, I'm going to leave the Teensy based remote control stuff in there because it's already put together and it works. And then on my new one that I'm building here, I'm just going to take this board, and this should, for what I want to do, it will work. And then if I just use a RS or not RS2 to use a asynchronous serial interface instead of CAN for this one to talk to the other talk to this board, which is going to be the one that's doing the motor control and controlling the steering and reading the quadrature, doing odometry and everything. So that way, that will it'll do the same thing, but I'll just throw out that CAN bus, so I don't have these weird requirements to keep that happy. So anyway, I've been collecting that stuff, and I just need to sit down with a soldering iron and start hooking stuff together, and maybe in a few days I can get to the point where it works. And again, the whole point I built this small one, there was 2 reasons. One, I wanted something that was smaller because it's a real pain. Even though I'm on the bottom level of this apartment building, I still have 4 steps. I have to go up 4 steps to get to ground level to go outside. And I the way I built the other one, it's I can get it to go up and down stairs. You just pick up the front and treat it like a 2-wheel cart, and you just go to the steps. And you get up the steps and you go thump, 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 thump going up. And if you want to go down, you just go thump, 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 thump and go down. And that's a pain, and it's heavy. So I figured this little one get to the point where I could just pick it up and carry it up those stairs. And then so I was making it smaller. It's quite a bit smaller than the other one, but it's still, for some reason it got heavy real quick, and it's partly because of it's got in the back, it's got wheels with steel rims. It's got 2 DC motors. It's got a steel axle. When I pick it up, it's still, even though it's small, it still weighs like 30 to 50 pounds already, and I'm not sure why, but so I might look at that some more. I just want to get to the point where I can test it and see if I can drive those motors on the back and have it do something reasonable. So I'll have to get back to you on that and say how that's working out. And I still keep looking for a mechanical differential that I can put in the back, so I'd have a mechanical differential and a motor and then some kind of gear reduction to run the whole thing. But I can't find anything convenient like what I put on the Sammy robot. It's got that uh, uh, transaxle from a mobility scooter. So it's basically a nice molded unit. It's made out of aluminum. You just bolt it down to the frame, and it's got a single wheelchair motor with gear reduction that goes to a built-in differential, and that all works just great. But it's probably larger than what I want right now, and it's probably heavier than what I want. I just cannot find a differential that's smaller than that and still beefy enough to work. And so I keep thinking about that too, but I don't know how that's going to go. I'll look around. Do I have anything else here? I don't seem to have. Yeah, I just looked to see if we're recording. At one point, I paused it. I want to make sure I didn't just waste the last 10 minutes babbling into the ether here. But it looks like we're recording. I don't see any other fun stuff. So I guess I'll just turn it over to Al.
Okay, pretty quick for me today. Um, I posted in Slack. Oh, well, I'll talk about monitoring since Jeff brought up monitoring, this is a light on a pump house in a place in Texas. Um, Continuing to monitor that. This is a little script that wrote that just shows the number of times the pump came on in the last, well, I set it so you could adjust the number of hours. So 168 hours is a week. And what you'd notice if you look through this data very quickly is, hey, looks like there's some cycling going on, and that constitutes a leaky system. And given the weather, we shut the darn pump off. And now my cow guy's got to go out there and try to find the leak before the cows run out of water. So thank goodness. I definitely am happy I took time to get this monitoring thing going, and it it pays off in helping figure out when we got a problem. But more in the robot side, I posted just a few minutes ago a video um, continuing to test a stepper motor and a magnetic encoder and a series of magnets wrapped around this plastic piece that I call a horn, modeling after this guy who's taken a series of three of these stepper motors and magnet deals and made a crazy micron level monitoring motion control system that, although I don't really have a use of a micron level microscopic sort of control system, I was fascinated by this use of a chain of magnets around that magnetic encoder. And so what this video does is just shows a little bit about learning more about what those pairs of magnets represent on this encoder and how to control the stepper motor. And I won't play the whole thing, but what it is effectively showing is that small. So this sort of quarter rotation, these magnets, this encoder, 21-bit encoder, can give you 18 million positions, which is just, crazy. Um, and I haven't figured it out. And where I'm at the moment is continuing to try to understand. This is his code. And although what I did a video on is, my code, is not his code. Um, he's got these two lookup tables that he creates during the calibration phase. LUT is his acronym for lookup table. And he puts those on the Pico, Raspberry Pico, and they survive a reboot. So he's, figured out how to use the flash, I guess, flash memory on the Pico. And these lookup tables somehow, helps him remember how to make use of all of those, what in my case ends up being 18 million positions. So I'm continuing to play with this, which is where I'm at the moment, and trying to understand how, I mean, I've stored stuff on a Pico, so it's not storing the table that's interesting to me, but how he uses these two tables to be able to get back to a particular position. So I know a little bit more, but I don't know. I don't know exactly how he's doing that and can't replicate it myself. The only other thing to mention is sort of off the subject of robotics, but a couple of weeks ago, I think I had just repaired my heating system in the house, and this induction, what they call a induction blower
Can you
motor.
turn off your screen sharing?
Oh, sure. Hold on. Yeah. So this invoice says this is a draft inducer assembly. And There's a hole on the backside that mates up to the I guess the heat exchanger. That tube is going to either pulling air, must be pulling air inside um, from outside. And this 120 volt motor um, died. And so, with the help of a friend who does maintenance at, commercial property, he got a price of $150 for this blower assembly and a little bit of help. Got that mounted just before the deep freeze hit here in Pittsburgh. So that's what's going on in my world. I got water leak in Texas and a new blower motor in Pittsburgh and 18 million ticks on my stepper motor that I'm trying to figure out. That's it for me.
Did you get a chance to figure out what failed? Was it just the motor and bearings seized up, or what?
Um, so there's a bit of a flywheel on the top of this thing that spins,
Yeah.
and it didn't completely seize. So my suspicion is, there's some, that magnetic wire, or not magnetic wire, but enamel covered wire. I'm assuming there's a slight short in there, and it's
Oh,
about to die, but it hasn't actually died yet because I could spin it when the blower kicked on, and I could tell that it was trying to turn, so I could coax it to run before it completely failed. So somewhere in there, there's some of that enamel wire that's probably got overheated, and it's close to completely catastrophically failing.
hmm.
So I just noticed I have another problem with Zoom that I see the little inset here with a person on is always showing me. It's not switching to other people. So that's yet one more thing I'll have to go track down. But that I just noticed that, so I'll point out that's what that's doing. So
Well, on this end, it switches back and forth real nice.
so it could be it's my video settings. I'll dig through and see if I can
Yeah, mine switches too.
figure out what to do with it.
My view is set to speaker view.
View. Mine is set to speaker view also, but I just noticed as you were talking there, it just had a picture of me and a little inset thing, and I don't know. Oh, actually, that was when if you're doing screen sharing, I was probably seeing what your screen was showing. So I don't know. It all baffles me trying to keep track of what it's supposed to be doing and when it's supposed to switch and all that stuff. So, but I guess I'm not gonna worry about it for the moment. So any more on your furnace, or is that
I'm all set.
okay? Bob, you got anything?
Um, I'm beginning to realize I don't know, futility. Anyway, when I got this Orin Nano, I had no idea what to expect other than past experience where you'd expect it to boot up and you could get started. Well, not so. Seems like they don't give you any software in the machine. You have to download everything off of their site. That I went round and round on that. And then there's always the conflict of version numbers between all of the software. You have to have the right Linux, um, the right operating system, Jetpack. Jetpack has limitations on what it can do with some of the Linux stuff. It's just a pain in the neck. If I was to do it again, maybe I'd try and max out Raspberry Pi with one of their AI boards. But I'm committed, so I got to struggle through no matter how many teeth I got to pull. I've been running it through ChatGPT, and I discovered a feature that says your view or your progress in review. So you type in the year, and then it gives you a whole bunch of stuff. You're saying, well, you did this, you did that, you got to do this. I put a post-mortem short report on the on Slack, but that doesn't really tell you a whole lot. Um, I'll see if I can get into chat and show you the report they generated. Start broadcast 3, 2, 1. Okay, now I'm sharing supposedly, and I go to chat, and up until this point, I've been trying to take small concepts and develop that, because there's a limit on how many times you can query, and they just shut you off at that point. Okay, yeah, your year with chat. Let's see, I'm in it now. So I'll go up to the top. And first, they give you a poem on what you did or didn't do. And I said, baloney. Just give me it straight. So this was the report. Most of it's self-evident. Technical areas we worked on, computer visions, how you used it, patterns that stand out. This is my calling card. I don't follow tutorials. I just throw it up at the wall and say, fix it. But I did recognize that I wanted to understand what's going on. They said they'd give me a technical roadmap and some other stuff, lessons learned. So over here on the right, I said lessons learned, and with no fluff. I did recognize I had to split the workload between the low level and high level. And then this takeaway, defined hard ownership. I'm still trying to figure that out. So I'm thinking low level stuff is supposed to be on the Pi, and the high is on the Nano. But then I don't know. This board owns decisions. I gotta decide what kind of decisions I want. And all along, the bottleneck kind of confirmed what I suspected. It's not the coding, it's all the drivers that you have to find. Let's see. And you've got the kernel you have to worry about. You got the tree driver, and then of course the jetpack. Let's see. Cameras are systems, not devices. Which again, I thought, well, maybe it's like other Raspberry stuff. It just works.
Scroll back up, Bob, to the headless comments. What was it saying about running headless?
Okay.
Keyboard plus mouse plus monitor saved hours. Oh, okay.
Yeah. And again, it's my misconception of what the cameras were supposed to do. They're systems, so you have to figure all that out. And you have to sync everything for SLAM. And I ran into some terms I didn't know, like the FSYNC, and I'm getting there. And the whole idea is to timestamp the frames so you can coordinate with your other software. I said, well, I like simple, so I said, give me all in one. They said, oh, you shouldn't do that. should break it up. And let's see. And I don't know why this is a problem, but they do. It is. I was jumping the gun too much, saying, okay, give me code I can just launch. Well, that's not a good thing at this point. And equal performance. This was one I was having a lot of trouble with on the whole concept of pipelines. When I try to override or erase or write over and try a new version, it doesn't wipe the disk clean. And it said there are more broken pipelines somewhere that's interfering. So then they gave me some commands to completely wipe it. And I was scared of that because I figured, sure enough, I'd do my main project and wipe out everything, wipe out my laptop. But after about an hour or so, checking, double checking, whatever, then it got going. The other thing I found out was one report said Firefox is supposed to come with it. Well, it didn't come with this one. So I went down that road trying to get that working. And it seems like there's two versions of Firefox. And the only version that would work is something called Firefox ESR. That's the most stable iteration. And some warning signs. It recognized I'm building a platform, not a demo. The big one, what I've learned, is everything is about timing, drivers, edges. That's where chat has helped find that stuff out. It said, next, do I want this stuff? And I said, well, I don't know. Give me a post-mortem technical report. So that was the objective. The outcome, most failures were non-code issues. It was timing, drivers, system coupling. What went right was split it between the two machines. And I said, keep this idea. These were the good hardware choices, and keep them. But there are some failures I got to navigate. See, enabled. I need to understand this abstraction a lot more. What went wrong? The Wi-Fi and camera failures were because of kernel and Jetpack. The Intel is not supported by Jetpack 6, but it was supported at lower versions. So I went back and tried that, and that had a lot of problems. So I ended up saying to hell with it. And I reinstalled the Wi-Fi that came with it. And I also got a cable to go from the laptop over to the Nano. And it recognized the Nano right off the bat, whereas before it didn't. So I had a good connection between the two machines. This was a big one, the pipeline coupling. High timing was a root cause. I'm not understanding what was the timing. Premature, I tried to push too fast and make everything go. And let's see what else. Severity, what failed completely. Hardware was not modular. Root causes, assumed drivers existed, assumed pipelines were isolated, assumed timestamps were trustworthy, assumed stability before verification. I had no concept of that kind of stuff. Corrective actions. I have to really look into this clock ownership thing and verify that the sync is working. Let's see, hardware selection, promote stages. Final note, was the project a failure? No, that's encouraging. Was it inefficient? Oh, hell yes. Let's see, that was a good failure. What do you want me to do at this point? And I said, put the postmortem into a PDF. And that PDF I just posted to Slack, but it isn't the one that I was anticipating. Let's see. What's different? So I said, download this, and I wanted more detail. And it said, this is more than what I had before, more explanations. If you want to go deeper, you can add timelines, et cetera, et cetera. And at this point, it sent me a message and said, you've run out of tokens to ask. So I'm dead with this thread. But one thing I've learned with these different projects is that when I hit a wall and says, I'm out of tokens or whatever it is, I can start a new project with some of the information and keep going. So as long as I kept my little project small, that's no problem. So when I go to put together the big one, it seems to know what I've done already, and it'll come back up with the good stuff. So that's where I'm at right now. And I think what I've done is I've taken the beginning conversation description or specs from 2 projects, and I put each one in a text file, and I'm comparing the language between one and the other and some of the other projects, saying, what do I want to do? Trying to be real careful of kind of like what they said, what I should do is give it a deeper thought on how I want to do things. So that's about where I'm at now. Before I did this, I did do the 2 main ones that I was working on is this NanoBot Build with a small b. That went pretty good. And then I realized I put in some stuff I didn't want. So I renamed it, and it's NanoBot Build with a big B. Now I've got many more tokens I can use to get it up and running. So at that point, when I just started doing the build, I realized, hey, I'm duplicating my questions. Then I decided to explore that year in review. And it kind of confirmed what I had an idea of, but I couldn't quantify it. So that's where I'm at now on the software side. And I'm reconnecting electrically all of the modules, the Nano, and I've got Cat 6 going from Nano to Raspberry. I've got cards in both that are working. I think I'm going to hold off on the stereo and just focus on the webcam. And I've got I'll just show up a picture. And I'll get out of this, go back here. And okay, I don't want to share my screen now. I don't know why. Stop share. That's what I got to do. Okay, so now I got to turn the camera around. And let's see, how do I do that? Oh, there it is up in the upper right corner. There we go. So I've got the Nano there. I've got the two Adafruit boards wired up to the motor and to all of the servos, even though I'm only going to use the webcam for now. And the Raspberry Pi is plugged in. And right now I'm just using wall power for both machines. Eventually I'll get to the battery, but this is more consistent. Next step I have to do is wire up the battery voltage for the servos. And that'll get me going so I can test everything before I convert over to the battery power. So that's about where I'm at. That's all I got.
Bob, you haven't found anybody who's trying to use that Jetson Nano online that you can follow? I mean, it's like blows me away that you have to deal with something like Wi-Fi.
Yeah.
For goodness sakes, even Wi-Fi doesn't work on this thing?
Well, now it is, yeah. Because when I found the uh, Firefox UCR and got that working, that told me that the Wi-Fi is working now. Oh,
But as far as following, like there used to be guys who sold a robot and they had a build that you could download and put it on a Raspberry Pi. I think they sort of
oh,
settled on a Raspberry Pi 4. I mean, there's nobody you can find that has
um,
an image you can put on your Jetson.
I haven't looked. They have a robot software package called Isaac, but then I've heard conflicting or saw conflicting reports that because I only have 8 GB memory, that may not work. I'd have to go with the solid state drive, which would give me, double or triple. So I'm not there yet.
Hmm.
So,
That's
yeah,
crazy that you're out there in the wilderness on your own.
I think that the biggest problem I have is I'm too impatient. I want it now. And I'm just going to have to take the time to do more research. But if I can get this working and I get the video where I can see it the way I want it, then I'll spend more time on the AI packages trying to understand that whole concept rather than shooting in the dark.
Hmm.
But right now, it's just the simple thing of that can be done with Python and letting chat put together the code. Once I get that going, then then I'm more encouraged to do the right thing and research more.
Well, good luck. I mean, I wish I could be more help. I've just never dealt with that
Yeah,
nano thing.
I think if I had a good background in Linux, it wouldn't be so confusing. But the only programming I had was almost 40 years ago. So
I'm all set. Thanks.
What
yep.
what kind of programming were they using 40 years ago?
Oh, when I first went to the U, I took Fortran, and then I tried C, and I gave up on that and went to Basic over on the St. Paul campus. And that was more with C on the Minneapolis campus. You had to have a math background. So they say, okay, write a program that does the what's that number? Oh, it keeps building. I forget what it was, but they were saying do these mathematical things in C. Well, I didn't understand what your what the mathematical problem was. It was where you put in one number, it generates a number, and then oh, I can barely see the name of it in my mind. I can't remember. But I said, what in the world is that? And I suppose if I hadn't jumped into C like I did without any background, it would have made more sense.
Yeah, I ended up taking Fortran very early on, and then actually when I went to Unisys, they got a VAX 485, I think, to
Yeah.
run a CAD system, and that was all in Fortran, and I played with that a lot, and so yeah, some of this old stuff. And it turns out that Cray uses Fortran as one of their preferred languages to do all their quote mathematical stuff that they do.
Wow.
So it hasn't completely died, but
And it didn't help that I had a TA teaching the class, and he was an international student. I forget what country, but he could barely understand his English. And when he wrote on the blackboard, it was very cursive, kind of like what you'd see in Southeast Asia. And then the other thing I didn't like about Fortran then is you had to do everything with cards. So you put a stack of cards in, they said, no, you screwed up. Then you have to figure that out, and then you put the cards back in again. And it just, but what about that time after the C class and stuff, I had some money available and I bought the Radio Shack Model 100 that had basic. So when I took the basic class and they say, do this, compute interest on a loan or this or that, concepts I could understand. Then if I ran into a problem, I'd say, okay, prof, here's what I got. What am I doing wrong? And that helped a lot. In fact, I still have that Model 100, and I'm hard pressed to let it go, just for nostalgia, if nothing else.
yeah, I guess I'm done for today.